Welcome back. This is an Aleks training video on identifying intermediates in a reaction mechanism. If you remember that an intermediate is a temporary product in the middle of a reaction, so your reactants form some kind of a temporary product, and then that product, that intermediate, is then itself reactants in a second reaction that when you look at the entire reaction, those intermediates just disappear. So you can identify an intermediate knowing that it's the product of the first reaction and the reactant of the second reaction, and that you don't see that ever again. You don't see it in the product at all. So let's look at this mechanism. So if you have a mechanism here, remember a mechanism is just a proposal of how a reaction occurs if it has more than one step to it. So you have some big ugly yucky thing here with methylbromine something, and then it's going to make some kind of a cation and bromide ion, and then it is then used in the second step. If you can recognize that, this is in the second step, and then it reacts with hydroxide in the reaction vessel to form a product. Okay. Well, your intermediate is whatever is in the products of your first step and the reactants of your second step, but you don't see them anywhere else. Okay, so let's identify them. Okay, so let's identify them here. So I see this guy as a product in the first step, and I see the same one, whatever it is, as a reactant in the second step, and I don't see it anywhere else. That's an intermediate. Okay, I see this guy as my product. Okay, I see this guy as my reactant. I see this as a reactant, and I see this as a product. Okay, so anything on the left that doesn't cancel out, it's almost like a spectator ion if you think about it. Remember, a spectator ion was anything that was an ion on the left and the right, and so it didn't participate in the reaction. This is the same thing. You're making a product, a temporary product, here, this guy, and it's also going to be used in the second reaction and then essentially goes away. All right, so that is called an intermediate. All right, so write the overall mechanism. Well, cancel the intermediate, put everything that's on the left, and put everything that's on the right. Okay, so what's that going to look like? That's going to look like CH3, 3C, Br, aqueous. Okay. Is there anything else on the left? Well, I don't want the CH3,3C plus. I don't want that because it's going to cancel, but I do see the OH. It's on the left, so it's going to be one of the reactants. If you think of the whole reaction as one reaction, it's going to be one of the reactants. Okay, then you're going to have everything that's on the right. Okay, so everything that's going to be on the right is going to be CH3, 3COH, aqueous, plus Br minus aqueous. Okay, so I think that these could be in any order as long as the front two can be in any order. OH I need to do is aqueous as well. Okay, associated aqueous, OH minus aqueous yields Does that make sense? Hope so. You're essentially canceling what you see on both sides. Everything you see on the left stays on the left. Everything you see on the right stays on the right. Okay, second question. Are there any intermediates in this mechanism? Yes. That's what we marked in red. That's an intermediate. what is the formula of the intermediate? And if there's more than one intermediate, just put a comma there. I only see one here, and it's going to be CH3 C+. Okay, so actually this is pretty simple. I think you'll get it.